Yeah, quiz 4. Sorry, I hit that. I was so excited about it. Quiz 4, which means we're into the second marking period. You are 1/4 of the way through calculus, and actually even a little bit more because the test is in early May. Okay, so problems to discuss before quiz 4. Since I wrote that at the top, right up here, we should probably go over them. Okay, for the first one, problem 1, find the following limit. We've got this limit as h approaches 0. And I see the cosine of 3x plus h minus cosine 3 of x. Okay, so I see all of this, but what I really notice is the limit as h approaches 0 is going to be the same thing. This is, remember that thing from before, the limit as h approaches 0, f of x plus h minus f of x over h. And then your answer to this is the derivative of f of x, or f prime of x. So what I'm really looking at is f of x is right here. My function is cosine 3x, which means my derivative, the derivative of cosine, and any trig function that starts with a c, the derivative of cosine is negative sine. But this is the chain rule. There's a function, 3x, inside of a function. Wow. So the chain rule applies, don't forget it. So I have negative sine, I leave the inside alone, times the derivative of the inside. So times 3, really, really important. Someone will forget that. Don't let it be you. Make sure you're not able to just do ones like this. What if I changed it? Instead of limit as h approaches 0, but instead of saying cosine, I said sine, or, and it was very similar, or secant, or tangent, or one of those. Make sure that you memorize all of those trig functions and what their derivatives are. It says it also on here at the top. Memorize or be able to find the quotient rules of the derivative, sine, cosine, tangent. So if I'm saying it here for all of them, you should definitely do it. And if I put, I don't know, tangent of 3x in here, my answer would be secant squared of 3x times 3. So you're still doing the same thing. Okay, so that's the first one. Problem number 2, moving on. It says find the equation of a tangent line. If I'm finding an equation, I need a slope and I need a point. So in this one, my slope, I can see I've got 3x times cosine of x. Yeah, product rule. So I'm going to do the first times the derivative of the second plus the second times the derivative of the first. So what's going to happen is you are actually going to go through and solve that. So I'm going to say f prime of pi over 3, 3 times pi over 3, negative sine, pi over 3, plus cosine, pi over 3. So now would be a good time to go through and actually try that. So what is negative sine of pi over 3? Okay, so the way that we're going to do this then, so I'm going to say this part, I automatically get pi. Sine of pi over 3, there's lots of ways that you can do this, but if you struggle with just doing sine of pi over 3, the way that I do it is I think, okay, this is pi over 3, pi over 6, and then I say this is the smallest angle, so across from that would be 1. Pi over 3 would be the next side, so I would have square root of 3. And Pythagorean theorem, even if you can't remember anything else, 1 squared is 1, plus the square root of 3 squared is 3, so this would be 4, right? Square root of 4 is 2. So in here, if I want to know the sine of pi over 3, it's still going to be negative. Pi over 3 is in the first quadrant. So sine is going to be opposite over hypotenuse. And then I've got plus cosine of pi over 3. Oh, I should have done this all in the same step, sorry. Cosine of pi over 3. Very similar. So pi over 3 here, I've got cosine, so I'm taking adjacent over hypotenuse. So I'm saying 1/2 times 3. And then I do all this work, I'm running out of room too, but I would say this would be, this is the equation of a tangent line, so I'm just finding the slope at a point. This is all f prime. So really there's not many things that I'm going to simplify here. This is my slope. In order to find the point, I'm going to go back up to here, f of pi over 3. So I'm going to say 3 pi over 3, I'm using this equation, cosine of pi over 3. So I get pi times cosine of pi over 3. Cosine will be adjacent over hypotenuse. So f of pi over 3 is pi over 2. F prime of pi over 3 is this whole mess. So then I say y minus y1, because I get that from here, is equal to m times x minus x1. And I'm running out of room, but I'm going to write it anyway. X minus y minus y1 is equal to m times x minus x1.